The shell can call functions in a separate task, and sp function argument repeat n function arg1 periodic seconds function arg1, and examples are setting or creating a global variables just like this: drvxy debug str is equal to string, calling functions printf percentages of the same note, outermost parenthesis are optional. So things that do not work are constructs like C constructs: if, switch, for, while, floating point, printf percentage d more than 10 parameters. So now the programming techniques. So why globals are evil? Global variables with the same name in different modules or the same piece of memory. Problem: two different modules may mutually override these values. Solution: make variable local to one source file with static. And solution 2: prefix global variables name with module name. So wrong way of writing is, just see here, integer card underscore count. This is internal variable and debug is an external variable. So the right way of writing is static int card underscore count and external variable, and int drvx debug equals to 0. This way all instances of threads, drivers, SNL program share the same global variable. Problem 2: two instantaneous instances mutually override their values. Solution: wrap variables in a structure, allocate one structure per instance. So wrong way of writing it is, values for one card is static char pointer address static int ivec, and the right way is use a structure drv private and struct drv private pointing to the next character pointer address integer ivec, and then access it through static drv pointer first equals to null. You should able to point it to the null. So this is the right way of writing the global variables of the second instance which we were talking about. Debug and error messages are vital. One is failed early and loud. Make message descriptive. What happened when, where, under which circumstances. Bad is error read. Good is card signal to read timeout after 5000 milliseconds, that is 5 seconds. Write error and debug messages to the std error. So make debug messages switchable, perhaps multiple levels. So global switches: int drvxy debug equals to 0. Message: if drvxy is greater than or equal to fprintf standard error. And then be paranoid. Error checking is the key to a stable system. Stability is limited by the weakest point. Check arguments to API functions, especially shell functions. Never trust a user, not even yourself. Always check pointer argument for validity. Writing to null overwrites the interrupt handler table, so be careful. So check results of system functions. malloc, fopen, system functions may fail and return null or error, and using these values unchecked may crash the system much later. Check for impossible values, example in case structs. So next is subroutine record, sub and genSub. So we look into the sub now. So 12 input links INPA to INPL, 12 field input fields A to L, that is record copies from links to fields before calling user functions, and either use a input link or write directly to input fields. Input fields are all of type double. User functions can use A to L and write result to val. SNAM field contains name of user function. INAM contains initial function. Functions get pointer to record and have access to all fields. Field names are lower cases a comma. So there it is uppercase and here it is lower cases. So subroutine record user function. Inputs are in field A to L, out goes to val, all doubles. So example, accumulate A star B to val. So hash include, just look at this example. So subrecord.h. So I have this method or a function integer which returns of the type integer, and struct subrecord has been passed through value equals to record value plus record a, and this is how we associate with that particular structure which we already wrote. Specify name of the function in sname field of record, and just like this, record sub comma dollar name. Here in this case, just check like snme is subroutine and the name is subaq, and inpa it's input, dollar input, and inpb it is dollar scale. So subroutine record initialization. How to initialize a subroutine record? Optional initialization function. So just like this, record underscore value is equal to 1.0 and return 0. The specify initialization name in inam field only. Just like this, just we discussed that the similar way. Field snam subaq, field inam subaq init. Initialization function runs only once at a boot time. Advanced asynchronous subroutine record. If function takes long time to complete, so run calculations in separate work thread with low priority, setup thread in init function, store data for inter-thread communication in tpvt field, and trigger work thread from record function. Return 1 from record function to signal calculation not yet complete. Reprocess record when calculation completes. Use callback request process callback. So packed field is 0 in run first run and 1 in second run. So return 0 from record function to signal calculation complete. Run other value, example error or to failure subroutine. So asynchronous subroutine stub. So these are all the header files: tasklib.h, semlib.h, error.h, and callback and subrecord.h. So private data for record, type def that structure, error status like error status result, trigger for work thread, callback for reprocessing. So then these are all prototypes of our subroutines. So then this is how get private data, loop for forever, wait until I take semaphore take, semtake, do some calculations, leave results in private value, leave error in the private in reprocess record, and then as I mentioned you earlier, callback request process callback by passing these particular fields. So user function subroutine. So get private data, once again inam missing, and then if record packed equals to 0, now sem give trigger work thread. So return 1, signal not yet done as we discussed earlier. So then second run error in work thread. So you need to return the status of that structure priv, and then update record signal. If signal is done, return 0. So add error messages just like this. So if you don't do so, we cannot trace out what is actually happening, whether it is in asynchronous subroutine user function is not giving any acknowledgement. So now into the sem id trigger, initialize task id, then sem id trigger, asynchronous private, allocate a space for it based upon the size of asynchronous sub private, and if priv is null, return error which we discussed earlier. Private if triggers semaphore b create, so in first out and empty, and task pan that particular async sub with the name with the rest of tabs, and what is the task, and function pointer, that particular thread. So you just associate task id with the task span, just as shown in figure. If task id is error, return error number, and then record, as I mentioned earlier, we need to point to dpvt, record pointing to dpvt equal to private, return 0. So as we discussed earlier, here everywhere we need to return that error number to track the number. General subroutines, that is genSub compared to sub. So we just discussed subroutine. All inputs and outputs are arrays of user defined types. So input links INPA to INPU, they are A to L and here A to U, and output fields VALA to VALU, and links are out A to out U, all in form of arrays. So IO data types are FTA to FTU, FTVA to FTVU. So one of char, short, long, ulong, float, double, etc. will be that FTA, FTVA. So IO element count is NOA to NOU, NOVA to NOVU. Always set FT pointer and NO pointer fields, all used input and outputs. SNAM and INAM fields similar to subrecord. Asynchronous user function is not supported in this particular genSub. So genSub record must be loaded, require sync apps, SYN and then input output fields are small letters A to U, val A to U, where and void pointer. So notice the difference between that sub and genSub. So fields are pointers to arrays even if the element count is 1. So cast void pointer to correct pointer type. This easily crashes the IOC if FT pointer and no pointer fields are wrong. Always check field types and size. Do not process if type and size is void. So the reason why we work with an void pointer is with a raw memory or passing, is used for working with the raw memory or for passing a pointer to an unspecified type. So when character pointer were used for, we will go with the string copy, but here we go with a mem copy kind of environment. So we cast it with a void pointer to correct. The keyword void have been invented to mean no value, so void pointer was adapted to mean a pointer was adapted to mean a pointer to something. I don't know what exactly. Void pointers are often used with function pointers, that we'll see in the later of the discussion. Always check field types and size. Do not process if type or size is wrong. Exit with error message. So note this point, exit with an error message. So danger of crashing IOC is much higher than with subrecord, because here errors, arrays are more there. So checking every time the record process is expensive. So check once in init function when IOC boots up. Do not process record after check failed. So let's get into the initialization function. Check all data types and element counts. So field types are of menu f type short, menu f type double, and so on. Print descriptive error message if check fails. You can check for documentation network for field types. More field types are available for the same. Initialize any other private data, buffers, etc. assign structure to dpvt field only if all checks succeed. So here also we are going with a dpvt. So if no private data is needed, set dpvt to dummy value. Check dpvt value at start of user function. So do not process if dpvt is not set. So next is soft device support. So we just finished with the subroutine. Let's get into soft device support. So available for standard IO records, soft device support, AABA, MBBA waveforms makes a new DTYP choice available, and just like soft channel on the raw soft channel, only one input, that is INP and VAL are available. One output are available with soft device support. Example, timestamp for string in. So INP contains format string, file read for format, INP contains file name, FFT for waveform, INP points to other waveforms, integration for waveforms. INP points to the other waveforms. So writing device support, write record initialization and read function, define a global device support function table just like this. So write a structure, div integrate waveform, and report initialize init for record and get a IONT info read. Write dbd file to make function table known device form, which takes the arguments waveform constant device integration form and the name of it, that is integrate here. So the two essential functions are here are read and record. So device support table name has to be specified, and then record type. So waveform is the record type here, in this case dtyp string, and then link type constant means constant or link to record. So integrate waveform. So these are all the header files, devsup and recgba, alarm.h, dbaccess.h, waveform record.h is which are supported in VxWorks should be used. And first initially get the use a switch case statement for and switch case statement depends upon the INP type, what INP type I am passing through, and based upon that you write your cases. If it is PV link or DB link or CA link, break it, and default as we were speaking about record and this thing. Okay, return that as bad file field, if not return 0. After that return 0 for the whole of the function. So now so long div integrate waveform read function. So long status ni n equals to record NELM. So db get database get link through that by passing through INP from the record, INP FTVL BPTR 0 and if status is this thing, read and return the status. And here you see the error number is also required. Record nod equals to n. You just copy what is the value you got into the n from and then switch case according to the FTVL. There in your previous case we switch case according to the record type. So so dbf double, if case is dbf double sum equals to 0 point, initialize it to 0.0, and for write a for loop until that value of n, how many records are there, then sum equals to copy that BPTR and value in that BPTR. So then fill the arrays with the sum from and then break. So the case ends there, then return 0 and struct write a struct for it, div integrate waveform, which we discussed earlier with the report, record, read, get IOINT info, and then you have to initialize integrate waveform. Then state notation language. So in this second section, this is the last thing which we are going to look into: state notation language, state machine implementations for EPICs, that is our own very own do something when event happens. So events are CA monitors, record changes or timeouts. Do something can be any C code, C like syntax, understand many C functions and statements, escapes to real C code for special occasion. Easy to use CA interface like PVPUT, PVGet, monitor, and then any number of input and output records. So using SNL is like start state, if the state cold. So if it is greater than 225 point, this is just an example, degree centigrade, cooling on or cooling off, state if it is off, and vice versa. So programming cooling switch, initialize cooling. I'm just writing the small program. So cooling to device, cooling, double temp, assign temp to device temp, monitor temperature, temp, ss cooling switch, just the one similar to what we discussed. Now we are just, when this temperature to if the state is cold, if the state is cold, then temperature, when temperature greater than 3, just arrange the flag to 1, cooling flag to 1, PV put cooling state hot, or if it is state hot when temperature is less than 2.0, just make that cooling flag to 0, PV put cooling state cold, and this stuff. This is how we write a program for this case. So including C code into the SNL, escape single line with percentage, especially hash include, escape block with percentage, with parenthesis, and end with percentage. So accessing void avoid accessing global SNL variable from within escaped C code. Implementation depends upon plus or flag. And program calculator, here is a program calculator. Now hash include math.h, and just we escape single line with percentage and end with percentage. That's what we are doing exactly. Especially void my calc double I1 I2 double O1 O2, and then O1 is assigned with sine of I1 plus I2, and O2 is assigned with cos of I1 minus I2. So abusing SNL for calculation is start, idle, new input, and my calculation. We are just calling that my calculation. Double int, this is how it should be. Assign int 1, device input 1, input 2, output 1, output 2, and then monitor in 1 into EV flag new input, synchronous in 1 to new input, in2 to new input, SS calculator. We just implement this SS calculator when EF test and clear new input based upon that. My calculator is in1, it takes arguments, inputs and outputs, PV put out and PV put out 2. So finally compiling the C code for IOC using driver.makefile and require. So problem of compiling EPIC's code, we have many different EPIC's version in use: 3.1, 13.2, 13.9, 13.10, 14.8, 14.10. we have different operating systems, two VxWorks two versions of VxWorks, 3 versions of Linux, Windows, we have two different VME board types in use. In our case, we are going with NVMe 2300, NVMe 5100, and you can choose. This is just a case study, not specifically. You just don't have to follow our EPIC boards. You can have your own boards, but this case study could help you to check with how you can go with the MakeDir. Embedded Linux on Vertex, other systems like Vertex 4, Quasi-Lab, IOC. We want to run the same code on all systems. That means portability. Difference between the 3.13 and 3.14 is designed to be independent of VxWorks. Use OSA functions instead of VxWorks functions. Use EPIC's registry instead of VxWorks symbol table. Those things I will let you know in another video if possible. More complex build mechanism to build host IOCs. Incompatibilities between 3.13 and 3.14. New OSA functions are not available for 3.13. Registry calls must add or something like sub or genSubs, SNL state machines for device support. Makefile uses different variables name and mechanism, and make is a very complicated programming language. So the solution, driver.makefile. It is a sophisticated makefile that builds the same code for all EPIC's versions, for all operating system versions except Windows at the moment. So it builds a module that can be loaded with require. In many cases, it finds out what to do automatically. No need to write a complex makefile. In special cases, it can be configured. Originally designed for drivers, device support and new record types, it can be used for sub or genSub and SNL code too. The two flavors of module is global module, and commonly used code is in the global module or device driver, record type, etc. Installed into global driver pool with make install. Can be used by everyone. Gets version number from CVS tag. CVS location is g/drv/. Can be loaded with require. Local module. We just discussed the global module. The local modules here are locally SNL sub or genSub functions. So install to IOC boot directory with SWIT, where in global module we are going with make install. No interference with other modules. Local module does not need version numbers. So CVS locations A, X, F, P. So can be loaded with require. So high-tech drivers, CVS location G/drv/hytec. Okay, needs CVS tags with version like a high-tech one. I'm just considering here only the case study. We are not going digging deeper. Just for you to understand, we'll have some locations to make directory. Install to driver pool with make install. Can be loaded with require high-tech or require high-tech 1.4 or require with. This is how, if it can be loaded with. So genSub functions, x/location is id/gap, and function file x/id/gap/src e_2 gap.c. Tell project GNU makefile to build the code in src/ like this. IOC equal to build, IOC : build swit -v build clean make -c src $@ install to IOC with swit together with other projects. Just we require GAP. In your source directory, create one line makefile just like this. Include /IOC/tools.driver.makefile. Run make auto magically build a loadable module. Detect all .c, .cc, .c,
.cpp, .st, .stt and .dbd files in directory. Generates module name from directory name. So build for all APICs version. Builds only for VxWorks by default, but can build for Linux too. Finds dependencies on other modules, drivers. So levels out many differences between 3.13 and 3.14. If this is too much magic, you can configure it. Configure driver, source, code list, db list. Default is all files in current directory. Overwrite with source plus file1.cc, sources plus subdiv slash file2.c, and dbds plus xxx.dbd. Why overwriting? Files are not all in the same directory as the make file. Not all files should be used. So project module name, default name is directory name. If directory name is src or snl, default is the name of parent directory. Overwrite project is equal to other name. Why overwriting? Once again, I don't like directory names. So if I want to change the directory names, I can overwrite with other names. Directory name contains illegal characters like hyphen or space. Only numerical plus underscore allowed. EPIC versions to build, which we discussed earlier, also may change over time and depends upon machine. Exclude versions. Why exclude versions is code does not compile for EPIC versions. Code is not necessary for all EPIC versions. So operating system class, default in VxWorks only, all versions. Reasons, backward compatibility with old VxWorks dependent drivers, and this may subject to change also later on. I'm speaking about at the moment. Build classes equal to Linux plus or equal to Linux for both Linux and VxWorks. So here once again, why overwriting? Module should be used on other operating systems other than VxWorks. That means portability should be there. GenSub or SNL code for Linux IOCs. So header file installation, default is not to install any header files. Exception generated for header files for new record types. Overwrite headers plus equals to file.h. Once again, here low level driver on the other drivers may depend. For example, ASYN or IPAC, only important for global modules. So local modules are not installed for use by others. Make targets, make build. Builds a loadable module for EPIC or OS combination. Make 3.14, 3.13.2 builds only for certain EPIC versions. Make install, installs global module to driver pool. Make uninstall, cleans or removes global module from driver pool. Make help, pins loading modules is require is an SLS extension. It is used in IOC startup script to load modules. It checks if a module is already loaded with compatible version is okay, already loaded with incompatible version stops booting. It recursively solves dependencies on other modules, which we discussed earlier. So it loads the library and dbd files and initialize the module. Initialize means make functions etc available to the shell. Uses id and db load database to load the files. So using require is require in a string format. XXX loads XXX lib.munch lib.xxx.so or xxx.dll. So loads dbd file xxx.dbd and calls initialization function like register record device driver, require XXX 2.1. So loads 2.1 of library and dbd file only for global modules, not for local modules. Just like this 2.1 XXX lib 2.1.munch.so.dll. Require XXX test. So loads test untagged version of library and dbd file. Driver pool location. For driver pool location is this is the location. like instant base or IOC boot, EPIC version. See here I am speaking about EPICs. I am using EPICs boards. It can be your board or anything. I am just giving you the case study. /work /IOC boot and T slash R3 version you require, and this is how the libraries of global module are associated with the location of DBD. So same IOC/version/DBD. So location of headers /include, and in driver pool, example of link driver pool, this is how it is. Motor lib, this is how it is. Thank you.